Welcome to a video tutorial on first order RC and RL circuits. We'll be using a National Instruments MyDAC to show how RC and RL circuits charge and discharge. Capacitors and inductors both give a circuit the ability to store energy, and this lab will demonstrate how both capacitors and inductors charge and discharge. In RC and RL circuits, there's a time constant called tau, which is measured in seconds. For RC circuits, tau is equal to R times C, and for RL circuits, tau is equal to L divided by R. In both cases, when the capacitor or inductor is charging, it is at about 63% its final value after 1 tau and practically fully charged after 5 tau. For discharging, they are at about 37% of the full charge after 1 tau and fully discharged after 5 tau. The first step for this lab is to plug the MyDAC into the USB port on the computer and attach the circuit board to the MyDAC. Then, open up NI Elvis MX Instrument Launcher and start the function generator and an oscilloscope labeled FGen and scope respectively. Here's a diagram of the RC circuit that we use in this lab. As you can see, we have a 1 kilo ohm resistor in series with a 0.1 microfarad capacitor and an oscilloscope reading the Vin and the voltage across the capacitor. Here's a picture of a circuit constructed on the MyDAC. AO is used to supply voltage to the circuit and AI is used for the oscilloscope. The yellow wire goes from AO0 to one end of the resistor, and the brown wire goes from AGND to one end of the capacitor. The white wire goes from AI0 plus to the end of the capacitor that is closer to the resistor, and the orange wire goes from AI0 minus to the other end of the capacitor. The blue wire goes from AI1 plus to AO0, and finally the red wire goes from AI1 minus to AGND. As you can see, we have the yellow and brown wire completing the circuit, the red and blue wire reading the Vin, and the white and orange wire reading the voltage across the capacitor. Now, on your computer, select the window for the function generator. First, you will want to change the waveform to a square wave. You will also want to change the frequency to 1 kHz, amplitude to 2 volt peak to peak, DC offset to 1 volt, and duty cycle to 50%. After you've done that, select the window for your oscilloscope. You'll want to enable both channels and change acquisition mode to run once. Now hit run on the function generator and then run the oscilloscope. Hit autoscale and then adjust volts per division and time per division until it displays a graph like ours. You can keep hitting run to change your graph if you want to get a better region. The charging cycle is when the graph is curving upwards and the discharge cycle is when it is going down. Turn the cursors on and slide them around to take measurements. Find the voltage in the charge cycle after 1 tau. Divide that number by 2, which is our maximum voltage, and it should be close to 0.63. You can do the same in the discharge cycle and it should be close to 0.37. After you're done taking measurements on the RC circuit, you can move on to the RL circuit. For the RL circuit, we used a 1 mH inductor in series with a 100 ohm resistor. This time we hooked the oscilloscope up to read the Vin and across the resistor. Here's a picture of our RL circuit constructed on the MyDAC. The yellow wire goes from AO0 to one end of the inductor, and the brown wire goes from AGND to the resistor. The white wire goes from AI0 plus to the end of the resistor closer to the inductor, and the orange wire goes from AI0 minus to the other end of the resistor. The blue wire goes from AI1 plus to AO0, and the red wire goes from AI1 minus to AGND. Again, here we have the yellow and brown wire completing the circuit, the red and blue wire reading the Vin, and the white and orange wire reading the voltage across the resistor. Now you will need to change the settings on your function generator, but keep the waveform as a square wave. We found that for the clearest results, you should set the frequency to 10 kHz, amplitude to 0.1 volts peak to peak, 0 DC offset, and 50% duty cycle. Hit run and then switch back to the oscilloscope. Now hit run on the oscilloscope and adjust the settings until you get a clear picture. Take measurements the same way you did for the RC circuit. This time when calculating how charged the circuit is, you will notice that your result is further from 67% than it was in the RC circuit. This is the error caused by the MyDAC. This is a more accurate graph that we got when we hooked the circuit up to another oscilloscope. Now you can try finding new components in an RC or RL circuit to get a tau of 20 microseconds. How does this change the voltage at intervals of tau during both the charging and discharging cycles? That's all that we have for you. Thanks for watching.